Good morning, my outstanding friends. Today is the day. What is the wobble effect that has me and other scientists so intrigued? It has to do with the way a muon spins when it travels through a magnetic field. Well, what is a muon? And who are we talking to today? Scientific American. And who is the big deals in Scientific American? Well, it's Fermilab, because they're the ones that are doing the muon work. And this woman here, Marcella Carnara, is a particle physics at Fermilab in Illinois. Now, she's also professor of physics at the University of Chicago and so forth. And I intend to ask her about my work, and I hope she'll respond, but I rarely see that. Now, I am going to show you the muons, and I'm going to tell you right now, I'm going to do a little bit of bragging before I get started. I can make doodles with the best of them. I've doodled my way through physics all the way. Trust me, I know everything that they know. I've done it for years and years and years. However, I knew 50 years ago that there was no such thing as a solid nuclear core of positiveness, because it was literally impossible. And I proved it with all my work, and I was destroyed in physics and chemistry and everywhere else for showing the actual interactions, literally showing that this is not what they told us, and light energy is not what they told us. Light is atomic vapor, and I will show you that right now, because finally I have the evidence to support my claims of 50 years ago. Okay, let's see if we can see a little neutrino wobbling going on. So we got muon neutrinos and electron neutrinos, which is a black and a white ball. And when they concuss, the black ball stays a black ball and the white turns into white showers. The black ball, the white showers. This is the new electron flood theory, which makes the nucleus a dipole. And everything is made of these electrons, which are the black and white balls. Okay, and they were attached originally. This is when they exploded and turned into their separate components, which are the muon and electron showers. We're going to see this in great detail. Photons are these little packages, and protons are made up of 1,839 of these electrons. Now, what you're going to see right now is the photon constructed of two electrons, but the electrons also contain the dark matter muon, which nobody's ever seen before. And here it is in its magnificence. This is a photon, and it is coming through the air, and we can see the two electrons back to back. They are literally bar magnets, and then they start to glow, and the glow creates the wobble, and it'll eventually flip. And I'm going to show this quite carefully. But again, I don't know if I've shown this yet, but this is what my whole goal is here, is to create free energy, and we should be able to do it easily if we can do these muons, and I'm saying we can. So let's see if I'm right. You make your own decision. Okay, never argue for or against anything unless you know what you're talking about. So let's do a little homework. What's a muon? It is an elementary particle. Elementary means the smallest there is. That is not thought to be composed of any simpler particles. Well, where do you get down to the smallest particles that exist? Well, CERN decided if they smashed things hard enough, they would find little bits and pieces, and then they would try to figure out what those bits and pieces were. I say let's start with the smallest thing we can start with, which is light. Light it's everywhere, but we don't know what it is. Nobody has any idea what light is. I'm serious. They have no clue whatsoever. Now, I am going to show you light, and then we are going to see the muons, because muons are part of light, which is one of the smallest particles there is, and that is also totally unknown. So light, muons, electrons, we're going to see them all right now. Okay, an electron. This is the current thinking. An electron is a subatomic particle, that means smaller than an atom, nucleus, whose electric charge, so it has a charge, is negative. They think that it's a single charged particle, only negative. And it's one elementary charge. I disagree with that. Electrons belong to the first generations of lepton particle families. They call them anything they want, but I am going to show you what an electron is, and it is not a single elementary charge. It is a dipole. Okay, we're going to get into some of the light experiments we did using pulse red laser, which is nothing more than light. So what is light? Light is electromagnetic radiation. Well, what does that mean? Electro means electrons, electric polarities, push to shove, magnetic, electromagnetic. So it's a particle. Radiation means it's going out, it's radiating out. And it's in the electromagnetic spectrum. Now, visible light is in one little portion of the spectrum that we can see with our eyes, but it runs all the way across from any type of vibration, sound, all the way up to cosmic radiation, high energy, which you're going to see in a second. We did these experiments. I'm going to show you the experiments. Okay, so back to Muon Wobble, and that's a muon, and it is produced from a muon neutrino, which is attached to an electron neutrino. Very high speed, extremely energetic particles, and they smash into another medium. It's called Cherenkov radiation. The muon black part just does not change, and the electron part, which was a white part, explodes into showers. I show this right here. This is our experiment showing the black muon ball and the white electron shower, and then the recombination of the black muon ball to the white electron shower energetic particle, turning back into light. This is the smallest particles that exist as light that I know of, and they're made of what I believe is 2 electrons. Let me show you that. Don't forget, the black ball getting away from the white ball, and this was when they were attached, a black ball, a white turned into showers, black ball just went on its way, just as we saw right here. Now, how did we get to this point? And why am I talking about Muon Wobble? Let's see the Muon Wobble. Okay, I just showed you the black and white balls. I said the black balls were the muon neutrinos, and the white ball was the electron neutrino. Back to back, each one of them makes an electron. That's why the black's never been seen. They always thought it was just an energetic particle, because the energetic particle will radiate. The black does not. The black does not absorb, it does not concuss, it does not emit, it does not reflect. It's never been seen before, and the only reason we're seeing it right now is because we concussed it in such a violent manner that its energetic radiation is so enormous that we can pick it up quite easily with literally cell phones, and that's what we're using to pick up these. And they use them in the cosmic ray detectors now. It's exactly the same technology they're using at CERN and all the rest of them that are looking at these high energy particles. All right, we've been doing this a very long time. This goes back to 2014. The guys from CERN turned the pocket cosmic ray detectors from cell phones. They just made a little app so they could see them, because they're extremely high energy particles, and the CMOS can pick them up. And somewhere down there they see particles crash into Earth's atmosphere. They create showers of secondary, the muons, and that's exactly what they found, and they can see them. And they're saying it is exact same technologies that they're using at CERN and everywhere else. And it's time to get this public interest in gathering data and looking at this stuff. I don't know. It says it somewhere down here that it's the same technology. It's CMOS, complementary metal oxide semiconductors, and they can pick up these extremely high energy particles. So don't laugh at me for saying that we're looking at them, because we're finding them the same way you can see cosmic rays. All right, so now that we've settled that, we can see these particles very, very clearly. Now, we are right on top of the particles with the cell phones, literally watching the event occur real time in front of us. This is not any doodles. This is all real stuff. And this was, whoops. All right, this was the original pulsed red laser. All these little glowy particles here are glowing because there's a particle, which I showed you down here, that little box of black and white particles, is right here. But it has a magnetic field that surrounds us, very large. So everybody here is being concussed by the wave effect of the field driven by the particle. So the particle is way down in the center of a disk of magnetic influence. Everybody else is also has their own magnetic influence area. They concuss. That's what gives us the glow. Anytime you have concussion, you have glow. That's what's glowing here. All right? So this is all the gases in the air, all the free electrons, everything. But the main impact areas here are glowing like crazy. Now, what happens here? Again, any smashing of anything, any crushing of anything causes a glow. Now, here the particle is accelerating. The particle I showed you below, that four-banger there, is accelerating out of the wave into the venturi. And at this venturi, they literally separate, as I believe I showed you before, into the muons and the electron showers. Then they recombine over here. This is cold fusion. It creates fission here, no extra energy input whatsoever, just a passive, literally free venturi. It just needs to be engineered correctly. The particle accelerates, explodes, recombines over here. That's fission and fusion. In between here, look at the glow. Just look at it. Think about what's happened between here and here. Just consider the energy. This is all energy flowing backwards, outwards, like a bomb exploding. This is literally an explosion, a gigantic explosion. And that's why you don't see these waves here. They're here. The only reason you see one here coming in is because it's exactly directly in line with the venturi. And this is a single slit. This is not a double slit. So these interference patterns are not interference patterns. These are what they call fermions, which are not, they don't like to be, they're antisocial. They don't want to be next to you. That's why they're exploding like this. They get the hell away from me. I can't. What am I going to do? I'm stuck. And they can't. And all of a sudden they get out here and it's okay. Now you just get away here. I'll stay here. You get away. You get away. You get away. And that's why they set up these patterns. Then they recombine with the black particles that went all around. Right here they recombine. And we show this in extreme detail. Now, the Higgs fields and all that stuff. So let's just see the recombination. And here it is again. This is right at the venturi. You see it? Those are those black balls. They don't care about being next to each other, right on top of each other. No concern about that whatsoever. The white says, stay away from me. And that's why they explode here. And only the white can go through. And I'll show you why, I believe why. And then I'll show you why the wobble happens. But between here and here is a complete separation of charges. I believe right here we can do something serious. Or maybe it's right here. I don't know. Or maybe it's right there. Well, I know it's going to have to be beyond the venturi. Because the venturi is the crusher of the fields. Now, let's see the wobble. And I can explain the wobble because it's a charge on that electron. I'll show you. Now, before I go any further, I just want you to understand there's very, very little is known about literally anything, to be perfectly honest with you. The current unknowns are light. They don't know what light is. They don't know if it's a particle or a wave. They think it goes all one speed. They don't think it's anything in space. They think there's a vacuum where light coming from the sun just isn't there. Gravity, that's a complete mystery why you drop something that hits the ground. No, I'm not kidding you. You have no idea. The current model has no prediction for any of this stuff. It actually predicts against it, and all of the evidence that's been seen shows that the current theory is wrong. They know this. You're going to see everywhere. New physics required. We need new physics, which is absolutely right. Now, matter. Dark versus reflective matter. We can only see matter that bounces light back at us. All right? That means we can only see the electron portion of matter. The electron is concussive, explosive, push to shove. We bounce a particle in, it's going to bounce it back. We see that as colors and all that stuff. Now, but the dark matter says, I'm not doing anything. All I want to do is pull you white guys back in here and create matter. I want to create a ball. That's what the dark matter does. It's gravity and all that stuff. Now, light speed, nobody has any idea about this. They think it just one speed. Well, I could show you, and I did show you, it accelerates. Very easily we can accelerate it using a Venturi. So that's wrong. They say, well, in a vacuum it doesn't, it's just all one speed. No, it's not, because if I can accelerate it outside of a vacuum, I could certainly accelerate it with inside of a vacuum, no problem whatsoever. Space is not a vacuum anyway. They think space is, outer space is just completely empty, but it is filled, completely saturated with electrons coming out of the sun and every luminous body, because light is particles. There's no question about it. I just showed you light from a red laser. Light is light. I showed you the particles. They have a bouncy reflective side, which we see as matter, which is light reflected back at us. We see something's there, so it's matter. The other side we never saw, the dark matter. Now, this is called electron flood theory, and here is my email. If somebody can bring this forward, because I'm not, right now I am on all kind of spam lists. Nobody wants to respond to anything I say, and I have been blacklisted by Fermilab. I'm blocked and all that stuff, because I showed this, and they said, I won't take 1 minute to look at your stuff. You're going to have to get peer reviewed. I said, well, what is that all about? I don't care about that stuff. I'm not out to make a name for myself. I just wanted this real. And this is what I'm saying is the photon. I just showed you, and I can show this in so much detail, green and red, and how they begin to stack up from the neutrino phase to this particle phase, and then to the separation phase. I think I already have, but I'll show you, I'll burn it into you. Now, why does this bounce? Why is light light? I'm saying this is an electron, and that's an electron. Back to back, there's two bar magnets, and they're literally tiny, tiny, tiny bar magnets. Literally. They have a mass, they bang into things, they burn you if there's a ton of them coming down in high energy from the sun, obviously, if you get sunburn. They make conduction when they hit solar panels. They drive electrons because they bash into them. Now, why does this wobble? Why do they say these wobble? Because they're wanting to find out about these muons, but all they're seeing is photon wobble. Or they might be seeing the muons or the electrons by themselves. I can't say, but I can tell you why they spin, and here's why they spin right here. Remember before I showed you the cloud of electrons that are in the air, and the particle was coming through, and they were little glowy bits like this, and they were just all over in front. Well, that's because the particle's going this way. You see how this is growing in glow, and this one is diminished in glow? The particle's going this way. The dark energy has no impact at all, so it's just along for the ride. They call it a carrier. It carries these explosive particles. Now this one is interacting now, and it's starting to accumulate a charge. And it's going to get brighter and brighter and brighter and brighter and brighter, and then it's going to go boop and pop, and then this one will go to this side, and this one will go to this side. This one will start to achieve energy. As it concusses with all the things that are bashing into it, it will become brighter and brighter and brighter, and then all of a sudden it'll boop, and it'll flop around. That's the wobble. All right? I mean, to me, this is not a competition of who's got the more doodles and numbers and calculations and mathematics. Just to me, this is, how can we make this thing improve people's lives? That's what the whole thing is about. I just saw something about, we've had 20 years of intensive research at Fermilab. They haven't produced a single thing that's of any consequence that I know of. If you tell me anything that's of any value that was done there, I'd love to see it, because I found nothing. And I see no interest whatsoever in this. They said, just go away. And I'm not going away. Okay, so let's take it from the top. Here we have the pulse red laser. Boom, boom, boom. All of a sudden it starts to accelerate because it has to get through the Venturi. As it starts to accumulate charges and starts to glow, remember I showed you that little spot was glowing? As that glows, they're going to flip. From the bottom, they're going to flip to the top. Flip, 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 because it's going to charge up, and then at that time, the push to shove will be too much, and it'll force it to reverse. And the other one now will be pushed to shove, but it'll start to glow, and boom. And they do it instantaneously. And guess what? The exact same thing happens to the Earth. The Earth itself will flip its pole, and I think it just did recently. to a solar minimum from a solar maximum, but it's 11 years between the time it charges up and then it flips its pole. And it flips its pole in 27 days. So the same thing happens with these electrons. They charge up and boop, they pop. And I'll show you that actually happening with a green one. All right, once again, that particle's coming in. Green is very powerful, so it comes in really strong. And then it shows its particle nature, just like here. And then this is the portion when it flips. I've never seen that before. They're almost always very clear definition. And this one here is in the process of flipping, I believe. That's my interpretation. But these are the neutrino looking portions before they start to manifest their real true nature, and then they explode and divide. But at this point, I believe it's in the process of flipping. All right, this is the process of light traveling until it becomes separated. Coming in, you don't see anything at all unless you're going to have some form of serious compression, which is way over here. Now, if you look up in here, you don't see any particles to speak of. You see nothing up there. However, straight down the line of the Venturi accelerator, you start to see them, what they call a neutrino phase. And the neutrinos cause a couple of different phases, and this is the flat phase, and then this is the sideways phase, and then the box phase, and then the explosion phase. But I pretty much always see the particles in this box configuration. I have never seen any other than that one green one I showed you a second ago. Now, so we have neutrinos turning into the actual seeing the particles, knowing that they're all the same bits, and then dividing over here. There's no question this is what's happening. So we now know that these, as far as I'm concerned, that's dark matter. It's gravity, it's the boson, it's the carrier, it's the muon. It has no interaction with anything other than gravity. It pulls the white back together, as we saw after the Venturi. Okay, so if you paid attention, I showed you that this is the photon, and these are each separate electrons, and they are obviously capable of having independent energy levels. That's extremely energetic compared to that one, and that's one here, and that's the other one. That's because this is coming forward, and we can see those little bitty particles down here impacting and causing that to glow. And I say that causes the wobble, and it will shift. Now, in a general sense, what do we have as an electron flood model, which replaces Bohr? Bohr had a gigantic solid, can you see that? Yeah, a little bit. Had a gigantic solid proton, which they know it's not solid because they can break it into a bazillion pieces, and they just don't know what the pieces are. Well, I'm showing them to you. These are the pieces that I showed. Now, I say that's the core of every nucleus. Is made of a bazillion little electrons, and the dark part of the electron goes into the center, so it's completely encrusted with the white parts. Now, this is the electron flood model. This is the whole thing right here. Electrons are not just an explosive particle that creates heat and light and all that stuff. They are attached to the black particle, which is what I showed you, which is they call a muon. Now, these are the most tiny stable particles. Electron is the most tiny stable particle, but it wants to be attached to at least one more electron, and that makes it into light. Now, they really want to be in a mass, a big ball, to create atoms and molecules and so forth. Now, but all matter, every single thing that there is just 100% made of electrons. They're only in separate masses. And there's a certain mass that becomes stable, and we call it a proton. And it has a value of 1 atomic mass unit. And that weight of a proton, 1 atomic mass unit, equals 1,839 electrons. If an electron weighs this weight, 0.0005438 atomic mass units. You divide that into 1, and you end up with 1,839 particles. Now, photons are 2 of those particles. Remember I showed you how it bashes and they glow? They're spinning, but that one bashes, it glows, and flip, it flips. And then this one will be in front, and it will glow until it creates enough of a glow, and it flips. Now, all matter greater than light, which is your atoms, creates a ball. It creates a ball. And the black core will be inside. You won't see the black core. You'll just see whiteness, which is the reflective part. We've never seen the black. The only reason you saw the black is because of the experiments we did. Now, the white surrounds the black, so you won't see that, but it is inside. The black is the muons, it's gravity, it's bosons, and it is dark matter. These are my claims. Now, I hope I have shown the evidence to support these claims, and I think I have. And if you look carefully, there they are right there. So we could have free energy literally, I think, within weeks, if someone would pay enough attention to this right now. And we get this, because this is as cheap and effective as it could possibly be. I can't see, this is the only way we're going to get out of the situations we have with the water, with the air, with the global crisis, with we don't have enough energy, we don't have enough food, we don't have enough housing, and people are starving, and it's just terrible, it really is. And it's all related to energy. 100% of everything is energy. If you have the energy, you can do anything you want. 100% of anything. You can grow food, you can clean the water, you can build buildings, you can create housing, you can make food and do everything you want. Anything you want if you have the energy. And that, my friends, if it's free, and I think we can make it for free, is the solution.